We are moving on to surface area and volume. Let's review a few things. What makes a prism, does anyone know, a prism versus a pyramid? Max.
The top isn't pointy.
Yeah, it doesn't come to a point. I have two flat tops, right? So this would be a hexagonal prism. The top and the bottom are congruent. It's flat, right? Whereas, I don't know if I have one. This would be a hexagonal pyramid because it comes to a point. If you still are confusing, pyramids are like what you see in Egypt. Pyramid. Let's try another one. What would this be? Name it by its base shape and prism or pyramid. Okay. What about this guy?
Rectangular prism.
You guys. One more. Cube, right? Okay. Does anyone know what surface area is?
The area of all the surfaces.
Yeah.
The surface area.
You were to find the area of all the sides and add them together. So it's the sum of all of the areas. We call these faces. The sides are sometimes we call a face. What about lateral area?
Just the up and down. Just the up and down, not the bases.
No, it's just the bases.
No, just the bases.
That'd be your base area. Lateral area is like the sides, the up and down, right? I think in football, when I throw a lateral pass, what does that mean? What am I doing?
To the side.
To the side. So it's like the sides. I can't go forward or backwards, right? You can go backwards, just not to the front. That's close. So the sides. Your lateral faces are just the sides. The top and bottom are called your base. The sides are your lateral area. Just a few other things. An edge is where two faces meet. So these little lines, these are your edges. The corners where two edges meet is a vertice. Counting them as your corners. And then what is the difference between a right prism and an oblique prism?
One's when you like tilt it, it's right angle.
Yeah, it's like I'm pushing it over to the side like it's slanted. So oblique means it's not straight up and down. Okay, let's try find the surface area of, what is that? Name it.
A rectangular prism.
Rectangular prism. Perfect. I like to be organized when I do this. I always start with my base area. So I label BA. And I'm going to trace out my base shape. What are the dimensions of that shape?
36.
9 times 4. Which is, I heard 36. But think how many sides have an area of 36 of that?
So,
2, the top and bottom. So I'm going to take this guy times 2. Okay, so that is my base area. Now I'm going to find my lateral area. So I'm going to start with this right side here. What are the dimensions? 6 and 4. How many sides have the same dimensions as that? 2. Take 24 times 2. Think of a cereal box. Am I done?
No.
Yep, the front and the back.
54.
Oh, you guys are on fire today. 54. 54 times 2. 108. So now we have to add them all up for our surface area.
220.
Can someone confirm?
Yeah.
Wait, what was it? I missed it.
228.
228. Feet squared. Perfect.
That's a nice tube.
So really what we're doing differently from last chapter is just putting a bunch of plane figures together and finding the area. Not too bad, right?
Oh, yeah.
Let's try another one. What kind of a figure is this?
Triangular.
Triangular prism. Perfect. Start with our base area. How do you find the area of a triangle?
Base times base. Half base times.
Yep. So half 12 times 12. What's 6 times 12?
72.
Yeah, I knew that.
And you guys see how there's a back triangle too? So I can multiply that by 2.
144. Cool. That's 12.
You could just not divide by 2, but then what if you multiplied it by 2 and then it'd be twice as big? That's why I want you to remember to always multiply by 2. Okay, now I'm going to start with this bottom rectangle for my lateral area. What's 12 times 8?
96.
96.
96.
Oh, we are good with the 96. What about that green lateral face? Yeah, we're going to have to do Pythagorean theorem. Is there a faster way than Pythagorean theorem?
No, please tell me there is.
Special right triangles, right? It's an isosceles right triangle, which means it's a 45, 45, 90.
How do we know this?
If it's an isosceles right triangle.
So it'll say that?
No,
Well, both my legs are the same.
Guys, I can't
Both
hear.
my sides are the same, so it's isosceles, which makes these angles 45. And that's a right angle. So what do you want to use, special right triangles or Pythagorean theorem?
12 root 2. 12 divided by root 2.
Which one is it?
12 times root 2. It's 12 times root 2.
You just gave us 4 different answers.
All he knows is there's a 12 and root 2.
12 right. Which one is it though?
12 root 2. 12 divided by root 2.
12 root 2, which is approximately what?
16.9 like 7.
Should we say 17?
So handy dandy.
Give me 1 2.
So 17 times what?
You got the last.
Let's focus. 17 times what? 8.
8.
Which is what?
136.
And then I have one more side. 12 and 8. I guess we could put them out times 2.
Yep.
Yeah. This is just
96.
2.
172 millimeters.
Yep, 194. Oh, yeah.
What do we get?
472 millimeters squared.
A very big number.
472.
On your homework, I want you to show me some work too. You can't just put it on your calculator, okay? Be better about showing work. Okay, so those were some prisms. Now we are going to move on to a cylinder. So we're going to see if we can figure out the formula on our own. What's your base shape on a cylinder?
A circular.
So how many circles do I have on a cylinder?
2.
2. So if I want to write the base area, boys in the middle, can you handle it? Like, why are we so excited today? Relax a little bit.
I'm here.
I think you called Siri.
Okay, so 2 pi r squared is your base area.
I would rather talk about your calendar and dinner plans. Brittany.
I don't have dinner plans. I don't know. Should we ask her?
She wants to make something.
Okay. And then what shape is this?
That is a
A rectangle. How do you find the area of a rectangle? Length times width, base times height. So our height we're going to call h still. But how can I represent the length? Think about it.
The circumference.
right?
Yes,
it is.
That's right, all the way around my circle's circumference. You know how to circumference of a circle?
Yeah.
Twinkle, twinkle, little star circumference is 2
Pi r.
pi
I
r.
heard that one before.
I already know it.
That's supposed to be like.
What's that? There you go. That is our formula. Base area.
Pi r.
Hey Siri,
Siri, leave us alone.
Please
Siri, what's my name?
I don't know why she's doing weird.
She might have a name.
Do all of them come out the little boxes like that?
Yeah, these are called nets. So if you unravel a shape, it gives you a net. You guys want to look at those later, you can.
I want to play with those.
Did we get the formula down?
Yeah.
Okay, let's plug it in. 2 pi, what's our radius?
7.7.
7.5.
Max.
What is this approximately? That's just calculator work. Type her in. Game?
I'm sure calculators.
No, that's another good one.
What's the height of our cylinder?
15.
18. It's on its side. What is that approximately?
About
847.
847.
Correct reading, so.
We round on those.
You can round.
We do like 848 and 3.
Sure.
Sweet.
So our total surface area is approximately
101.
we say 1201. Is that fine?
Equals.
Okay, and our last one's kind of a doozy. We are working backwards to find the diameter given the surface area of a cylinder. So start off by writing your formula for the surface area of a cylinder. That's step 1. And we're going to plug in what we know.
You know the height.
We do know our height. What else do we know? We know the height and we know
The surface area.
the surface area. So I'm going to plug this guy in for my surface area. Do we know our radius?
No.
No. So I'm going to leave it as an r. Plus 2 pi r. And our height is 21. So we're going to leave the left side alone, but can I simplify my right-hand side? Can I factor anything out of both of those terms?
2 pi is repeated.
2 pi, so let's do that. Is anyone confused what I did from one step to the next step right there? We just took out a 2 pi.
Why?
Because we're trying to make our life easier. I'm going to rewrite this as 21 pi though. So our goal is to find our radius, right? So how can I get rid of this times by 2 pi? So what's nice is, look, our pi's are going to cancel. And what's 464 divided by 2?
232.
R squared plus 21R. So I think we needed more practice with factoring, so that's what we have to do to solve this. So we gotta set everything equal to 0, and then we gotta factor. So I'm gonna subtract 232, and bring it over to the other side. This equals 0. So you guys need to guess and check what multiplies to negative 232 but adds to positive 21. That's how you factor though. Having good number sets and guessing and checking. So what are some ways to multiply to 232?
232 times 1.
Good idea, but that's not the right one.
3.
2 times
160.
Or you can divide by 2. You can divide by 2.
116 and 2. I heard 232 and 1. So these multiply to 232, but we want them to have a difference of 21. So they have to add or subtract to 21. Keep going. Yep. 8 and 29.
29. She is faster than me.
Does that work? What's 8 times 29?
232.
232. What's 29 minus 8?
21.
It works. Okay, now what do we do from here?
Set them
Don't
each,
know, I remember.
set them separately equal to 0 and
Yep.
Well, we work on a problem for 30 minutes and we get.
Boys, stop. Does it make sense to have a negative radius?
No.
So then our answer is
28.
8. I think we wanted our diameters. What's our diameter?
16.
16.
You will be thankful the more we practice those when you get to Algebra 2. Spend a lot of time in Algebra 2 on those.
Is that just about part Algebra 2?